Okay, I think let's make a start now. Hello, everyone, and welcome to the fourth session of the Hydrogen Energy Seminar Series, which is an initiative between Cardiff University and University of Wyoming to discuss the role of hydrogen in decarbonization and achieving net zero. Today, we have two speakers, Oliver Lancaster, CEO of iGEM. I'll let Oliver to actually explain what iGEM is and the role of iGEM and a bit of more about himself. And also the second speaker, Marco Pellegrini from University of Bologna. So the idea for today's session is 20-minute presentation by Oliver, 20-minute presentation by Marco. Then we'll go through questions from audience, and we are going to have some sort of panel discussions on hydrogen. So the title of the presentation by Oliver is Hydrogen in the Whole Energy System. I stop here, hand over to you, Oliver. Off you go when you're ready.
Okay, thank you very much, Mason. I'm the Chief Executive of iGEM, that's the Institution of Gas Engineers and Managers. My background before starting this role was in gas distribution networks and Future of Energy Manager, leading the kind of design of the future energy system across gas and electricity to achieve initially an 80% decarbonisation target, which became a net zero target. But as iGEM, as far as we're concerned, we're the professional engineering institution for the gas sector. We have thousands of individual members and over 400 company members who represent a significant part of the emerging hydrogen supply chain. We also own many technical standards that are used internationally, including for hydrogen blends and 100% hydrogen infrastructure. And our ambition is to be the world's leading institution for gas professionals, advancing the safety, reliability, and sustainability of energy. Thank you also particularly to Mason for inviting me to join you today. I actually have a master's degree from Cardiff University, so I have a good link there, and I've had the pleasure of working with Mason on previous innovation projects such as grid-aware smart hybrid heating systems that I know that National Grid is very keen on in their USA footprint. That's hydrogen plus heat pumps for homes that helps to optimize the total system cost. It's hard to talk about hydrogen without talking about the wider aspects of the whole energy system, or indeed really to talk about wind or solar or nuclear without bringing in the wider system and needing to get our arms around it all. So I'll try briefly, do hurry me along if I'm dawdling, to cover a snapshot of Great Britain, and I look forward to the discussion later on. Hopefully the slides will transition. There we go. Excellent.
I can see your notes.
Oh, can you really? Do excuse me. I don't really need the notes. I can get rid of those somehow. Let me just try shutting my laptop. Hang on.
Yeah. If you switch your screen, that hopefully should solve the problem.
Let me reshare.
Yeah, please. I'm afraid that's the same.
If you go up to the top there, it says display settings, click on that drop down, maybe presenter mode.
It won't let me do either of those.
What?
Right, I've ended the slideshow, and let me start again. That might be a bit more helpful. Try this. There we are.
Perfect.
Okay. Apologies. No, I don't really need the notes anyway. So it's quite helpful to have a UK gas heritage, just little introduction to it, for a bit of lessons learned from the past. So I won't go into the bottom part of this slide, but in 1792, which is rather a long time ago, the gas industry kind of started in earnest properly then, I would suggest. when gas was produced from coal to light a house and to provide gas for a torch and what have you. And that became something that Boulton and Watt offered then to industry to build gasworks sites for an islanded production and supply for industrial facilities. But then in 1807, the concept of centralized production and distribution came along. And then by 1812, that was then allowed in law, and the first public gas utility was put in place as a company in 1812 and started to distribute gas for street lighting in 1813. And the interesting thing here is that this islanded approach to town gas production and consumption transitioned its way because of the option of having a networked supply into the fall away of those islanded sites, because it made things cheaper, easier, and significantly it put the security of supply matter upon somebody else's shoulder further upstream in the energy supply. And looking at the hydrogen world now, there's definitely a space for islanded hydrogen production and supply. We're seeing it already here and there, but I would strongly suspect a similar kind of approach of transitioning to a networked supply as it becomes available. Not to say that island supplies wouldn't endure, some I imagine certainly will do, but that initial development of a network, as it was back in 1812, 1813, was for street lighting, but then co-benefits were realized for it being used for other purposes, such as for industry to get hold of a supply from it as well. And so looking at hydrogen, that similar approach of a network supply for industry and large power generation gives the opportunity for co-benefits for other demand sectors to be making use of this as well. So a little trip down memory lane there perhaps might be helpful. Just some brief context here in the UK as far as the decarbonisation challenge is concerned. As I said, it's gone from 80% to net zero about 3-4 years ago. And there's been some progress in some sectors, but as you can see there, energy has come down quite a lot. That's largely due to the electricity decarbonisation from the bringing on of lots more renewables, from coal power generation backing out. We've only got one left in GB, and then there's another smaller one in Northern Ireland. And in that time also, gas has been still relied upon a great deal for flexibility as that coal has gone away, and also to be filling in for nuclear that's been reducing in capacity as well as their plants have come to end of life. And on the right hand side there, you can just see the different proportions of emissions that come from those sectors as well, just out of interest, and that's the link to where you can get that data from. One issue for the gas system is it just carries on quietly delivering and hasn't really had much of a front seat in the energy debate for quite a long time, and it kind of only just woke up to it really in, say, 2014-15, and when biomethane sites were starting to be connected to renewable natural gas from wastes and residues. But just helpful to perhaps go over a couple of points here, in that, as I mentioned before, it's old. It's been delivering for 211 years. In fact, I know an asset that's, I think, 201, 202 years old that's still operational. Around about a third of all consumption, energy consumption, is for heat demand that's provided through this system. And although it says there 80% of demand met by gas at peak times, it can be above that, towards 90%. And about 85% of UK homes are connected to the gas grid for their heating and use for cooking as well. So that's about 23 million in total. There's a lot of pipe length involved all over the UK. And the government has been working on the options, the potential there is for displacing, to repurposing the gas system so that it doesn't transport fossil gas anymore, but transports hydrogen instead, and different appliances that can be used to use that hydrogen if we don't use natural gas instead. One thing that certainly goes underlooked is the storage capacity of the gas system. So there's actually storage capacity in line pack. There might be some local storage, beach storage as well, but the inherent storage of the system that's relied upon that includes within the geological structures, anticlines that the natural gas is coming from. That inherent storage is relied upon, and to replace all of that storage so that it wasn't coming from gas at all is equivalent to about 21 billion Tesla Powerwalls, which is quite a substantial number, of course. But the storage capacity and the value of storage and the low cost of that storage that we use all the time is not really appreciated. Part of the net zero energy system challenge, for as far as I can pick up, is that there's a low awareness of system dynamics. And that's not just across members of the public or people who might be making putting narrative and commentary out there in the media. There's actually, I think, in the whole people who work in the energy system, a low awareness of energy system dynamics. And part of all this problem is that there's a divided lobby on what we should do in the future. There's deeply held opinion that maybe face saving, that there's the particular view and what have you has been held for a long time. Or it could be that there's a business or an investment connection to one part of it. And unfortunately, quite a lot of the time, there's a lot of assumptions made about things that people don't know. And there is maybe a blinkering and a focus on just one small corner of the energy system that someone might be an expert in. I'm not saying I am by any stretch, but just that it's a huge system. It's very dynamic and we need to overall get a better grip of it. And it's all around kind of electricity generation, electricity consumption, and the networks that get it from A to B, and gas as well, powering industry. So all the industry producing products and employing people. It's fueling transport, and there's obviously some change going on with that at the moment, and it's heating buildings. And as I said there on the other bullet, the energy system is broad. Quite often, if you ask someone what the energy system is, they might pick out a few parts. Great if they pick out a whole string of things that are connected parts of the energy system, but it's definitely networks, electricity and gas, electricity generation and gas production, storage of all kinds at different parts of the system, and demand as well. So if I choose in my home to get larger diameter pipework for low temperature heating, to install a heat pump with my boiler or on its own, or to add some insulation measures, that's an investment in the energy system at a cost to me. But it might be that obviously doing some of those things would be a good thing, be cost effective, and help the energy system overall to be cheaper for consumers and me and my bill. But you can go far enough that it actually would be cheaper to consume more net zero energy than to over retrofit or over intervene in a building. And so we have to really consider all the different kinds of interventions you can make in the broad energy system to try to get a balanced, least cost solution that can be delivered quickly enough and practically. This is a really helpful tool from the University of Birmingham, actually, Dr. Grant Wilson. The link to it there is at the bottom. I've chosen some of the key parts, and as far as the data goes back in this, which is 12 years, I think, to show some, show some of the key points, the key headlines. And the blue part of that is very up and down seasonally is the gas consumption in the UK. And that big swing is largely related to the winter heating demand. And then the blocky line beneath it is liquid fuels for transport. And then the red line, which is a little seasonal, obviously, is the electricity demand. And then the green line beneath it is the growth of renewable electricity underneath that. And you might be able to see a significant spike in 2018 with gas. And in the middle of the graph, that was called Beast from the East. It was a very cold, prolonged period. With schools shut and businesses shut and people not being able to get in, everyone's heating system was on 24 hours. And so being able to have enough gas for heating and for power generation as well. It's not particularly clear, this, because it's something I've screenshotted on my phone and made a little larger, but it's one of those helpful apps that most of us probably have on our phones that we dip into from time to time to see what's happening and what has been happening in the energy system, and this is particularly electricity generation. I wanted to just point out the marriage in the UK, at least, between gas and wind. So the red line there is the large gas power stations, CCGTs, combined cycle gas turbines. The blue line is wind. And so when you've got low wind, gas generation is high to meet demand. And then when wind is high, you've got gas generation that is low. It doesn't currently go to zero, because gas generation is currently needed for maintaining a stable electricity grid. But interestingly, although the year-on-year amount of gas used in power generation in the UK has come down a little bit at a time, the reliance on the gas system for power generation as a flexibility enabler of renewables has grown. And so at the moment, on a 5-minute by 5-minute basis, electricity from gas could be anything between 7% at its very lowest to keep the grid stable, right up to over 70% of electricity generation from gas. And yeah, it's just working with the demand level and the availability of intermittent renewables at the time. The graph below just shows to hopefully most people here are aware that we don't have solar at night, and that winter at our latitudes anyway, you get negligible solar power generation. So this was just to make the point about the reliance on different sources of electricity generation for decarbonising any energy demand in winter. And so, yeah, it's not all that helpful for that particular purpose. I mentioned power generation and CCGTs. They're the big turbines connected to gas transmission system and electricity transmission system. But there's been increasingly over the last 10 years power generation from gas connected between gas distribution and electricity distribution that gets missed off all of that data that we saw before. And this is from flexible gas engines, sometimes called gas peakers, but they're not just about meeting peak demand of electricity. They are there for when generation from renewables aren't meeting what was expected when it was forecast the day previously. So if there's not as much solar, there's a bank of cloud that comes over, then all the signals will go to these generation plants to come on. And these are located all around homes and businesses in cities, towns and villages around the country. So it's all embedded within the same distribution network as other demands. And policy advisors, policy makers and energy regulators over here don't really have a good grasp of the same network down at the distribution level, serving all those different demands at the same time. Very much they consider them in a siloed basis, trying to make decisions on housing or industry or power generation, and there's the refuelers for vehicles as well. So perhaps a helpful point there, and it's 4.2 gigawatts from those sites at the moment, will soon be 6 gigawatts and continue to grow. And then there's also the invisible generation from the gas system that we don't see the data for at the moment, and that is in combined heat and power plants and buildings, where the gas supplies energy to buildings that then is used for heat and for power. And that will be a substantial capacity that's used at the moment and can be generating electricity to go back onto the grid. Trying to get my arms around that at the moment. So yeah, lots of buildings use that, including the fairly new US embassy in London with the low carbon energy centre with renewables in there, but also gas CHP. And that's what flexible generation looks like at a distributed level, just banks of gas engines and shipping containers. And the manufacturers have now made available hydrogen versions of these, or hydrogen-ready versions, can run on a blend and up to 100%. And the operators of these are asking for hydrogen to be delivered to them in all these cities, towns, and villages to be able to decarbonize their flexible power. So that's just what they look like, and they're all over the place. That's power generation. When it comes to industry, there's a mixture of possibilities around electrification and on fuel switching to things like hydrogen. And this is an example of one particular industrial facility that will be using both of those. So this is a steelworks in Cardiff Docks in South Wales that doesn't make virgin steel, so it doesn't have the blast furnaces and the coking plant that we have down the road in Port Talbot. But this is recycled steel, so the steel comes in to be recycled, it gets melted down with an electric arc furnace, and then there are currently natural gas mills for dealing with the recycled steel for turning into base products. And they're well on the way of planning the route to change over from natural gas to hydrogen, and we've actually partnered with them as iGEM on that for these safety skills and standards associated with the private network of hydrogen supplied to those uses. Of course, there's transport, electrification, natural gas, biomethane, and hydrogen. But in the hydrogen space, a great deal is obviously happening in the aviation sector. Rolls-Royce, Airbus, and EasyJet, and individual airports like Manchester Airport's got an agreement for a hydrogen supply pipe for refueling with a local industrial cluster. Lots is happening in this space, particularly testing between what works for local councils, local authorities for their bus fleets between electric buses and hydrogen buses, whether a mixture is right, whether one is better over the other, and trains as well. So that's an interesting space to watch with transport. Sorry, I'm on this slide. And this is, as I mentioned before, about the use of hydrogen and electrification in a building, in a home, and the co-benefits of homes having access to this kind of supply because of the power generation and because of the industrial demand that there is. Nearby towns, cities, villages could be converted over with the existing infrastructure carrying hydrogen instead. And so there are homes in the UK that are using hydrogen at the moment as demonstrator homes. But I'll come on to those trials with people living in the homes shortly. And the government here have been leading the way on developing the appliances for it. So the gas hob, gas oven, gas fire using hydrogen instead of natural gas. And that's actually a photograph of the chief executive of the Climate Change Committee cooking on hydrogen in one of those homes last summertime. Then industrial clusters, touched on this before, and the role of industry and the need for industry to decarbonise and decarbonise quickly. It's these industrial clusters that have been called hydrogen super places that are going to be accelerating the supply of hydrogen for the wider economy. And I'm aware of the time, so I'll quickly power through some of these slides. But it's these clusters where it'll all particularly grow from at pace. And this is an example of a cluster that's already got all these organizations waiting for a hydrogen supply of low carbon hydrogen from largely blue hydrogen with making it from natural gas and with CCS, but also green hydrogen supply in there as well. And then importantly is the connection up of all the industrial clusters with transmission infrastructure, shown in the thick green line there. But this co-benefit thing is quite important in the middle of the slide. Although it's only a small area of GB in those red areas outlined around these major industrial clusters, there's over 40% of domestic heat connected to the gas networks and 40% of HGV registrations in those areas. So you can see yourself a minimum viable product appearing here for pushing hydrogen into the economy. And the ENA have helped here with the gas networks in developing what the vision looks like for the transformation of the gas network infrastructure to hydrogen infrastructure, which is largely repurposing, some new, but largely repurposing of existing infrastructure. And going from 2030, which is the red there is transmission, blue is distribution, 2030 to 2035, 40, 45, 50. It's growing, and there's the interconnection to the European hydrogen backbone as well. But the colours in the background are getting darker as the distribution network is connecting demand as well. Lots of work has gone into the conversion of cities. This is an example of Cardiff a few years ago that was done, and how it was segmented over 3 years and then sub-segmented. But lots more work will be happening on top of this. But just to give you an example of the detail at the local level of what's been going on into this. Government have a lot of decisions to make. Hydrogen blending and hydrogen-ready boilers being mandated, decisions to come by the end of this year. And then the delivery of the major trials, hydrogen neighbourhood, hydrogen village, and getting to a hydrogen town in 2030. The hydrogen neighbourhood is being built right now in Scotland, in Fife. And this is just showing you it's green hydrogen from offshore wind electrolysis through to 300 homes, and they're oversubscribed for that. And that's just showing the network being laid. I was there only a few weeks ago when the roads that are being that are having the new pipework laid, so people can choose to opt into the supply or stay on natural gas as this trial happens. It's testing the homes, not the repurposing of the network. The repurposing of the network is being tested in the village trial, and this is likely to be in Redcar in the north east of England. Many more homes, leisure centre, school. More complicated, but as I say, repurposing the existing infrastructure to help government make a decision on the future of the gas grid for hydrogen in 2026 is their target. IGEM is supporting all this to be able to happen with technical standards for hydrogen, supporting our members, influencing on the policy level with our own papers, white papers, our own responses on behalf of members to the and a lot of communications. And these are all the organisations who help us on our hydrogen committee to deliver all this work. So I'm very grateful to them. And we do have a hydrogen knowledge centre that our members have full access to. Loads of research and reports there that I'd be glad to help you get in touch with. And I'm done. Sorry, a bit of a rush at the end. I'm really sorry I went over.
That is excellent. Thank you very much, Oliver, for the very informative presentations. We can now move to Marco for his presentation, and then come back to both of you for question and answer. Yeah, thanks. Marco, please feel free to share your screen when you're ready.
Okay, thank you. Can you hear me, first of all?
I can hear you absolutely fine.
Okay.
Yeah, I can see you. Okay.
Let's see if I remember how to share the screen with Zoom. It's working.
Yeah, I can see your slide fine if you just make it full screen. Perfect.
Okay, good. Well, first of all, I would like to thank Meizam and Eugene for asking me to taking part in this very interesting seminar series, and also Christine for the organization. And a few words about myself. I'm assistant professor at the Department of Industrial Engineering at the University of Bologna. And my research works is mainly related with mechanical industrial plants. And one of the topics on which we are working as a research group is hydrogen, and in particular, hydrogen application in industries. But today, I prepared something that is more, I would say, kind of framework for a discussion. So I will try to be on time, and I hope the information I will share will be useful for the following discussion with the audience. So I will give a framework of how hydrogen is now under big lens in Europe. So a few numbers about energy in Europe and how hydrogen can help us in the decarbonization with a particular focus on industries, as I said. The same exercise in Italy with some examples of projects on the pipeline and a kind of wrap up in terms of challenges and opportunities. In the near future, as I said, as a university, we have a lot of projects together with other research institutes and also with industries. So it's interesting for us to evaluate what is expected in the next 5-10 years in terms of research needs and innovation demand. Talking about Europe, if we look at the gross available energy, which means the overall energy supply, not only for energy purposes, we see that we are still far from being decarbonized. More than 70% of our resources are covered by fossil fuels. And if we look at the final energy use, I think that this is more or less the same for all the European countries. We have this more or less equal distribution among sectors: transport, buildings, and industries share the energy bill. But what is interesting for me is that usually when we talk about energy, there is this misleading and usually people understand that you're talking about electricity. Indeed, when we are talking about energy, also heating, it's included. And if we look at the numbers, heating demand is more or less half of the energy use in Europe, including obviously hard-to-abate industrial processes. And now I will talk about this topic more in detail. What does it mean? It means that when we think about decarbonization, we don't have only to concentrate on power production and use, but also on heat demand and how we can substitute fossil fuels also from that side of the energy demand. And if you look at numbers, as I said before, and in particular at industrial processes, we can see that there are a lot of processes, more or less half of the heat demand, that requires high temperature to be satisfied. And when I say high temperature, it means over 300, 400 Celsius degrees. So the alternatives for fossil fuels, if we look at the market, are not so numerous. I mean, electrification, heat pumps that are more or less two faces of the same coin, and the use of biomass can be alternatives. But if we go to such a temperatures, it's complicated to imagine solutions that are not related with the generation of synthetic fuels that came from renewables. That's why I think it's very important to keep in mind that we have to deal also with heat, and in particular heat demand from industries. Because if we don't want to become the industrialized region of the world, we have to think about how to deal with this concern. What is the strategy at European level? When we talk about hydrogen, usually it is not considered that there is already a market for hydrogen. Hydrogen is currently produced in Europe and consumed not for energy purposes, but mainly in the chemical industries for plastic production, fertilizer production. And there is a demand that is not negligible. 6.5 million tons every year are produced and consumed in Europe. And almost 100% of this hydrogen is produced by, once again, fossil fuels, and in particular natural gas. The European Commission proposes to produce 10 millions of renewable hydrogen by 2013, and also import a same amount from non-EU countries. Yeah, it's a lot of hydrogen. If we look at kind of conversion factor with natural gas, these 10 millions renewable hydrogen could substitute 20% of European demand of natural gas. So it's a large amount of hydrogen to be produced and managed over the current hydrogen demand. So there could be a combination. Hydrogen could be produced to substitute the one that is used as feedstock for basically chemical processes, but can be used also as a substitute of fossil fuel for energy production. But when we came to this point, it's important to keep in mind that these numbers are very big. It means that from a technical point of view, we have some problems, but there are also some concerns in terms of political impacts. So let's consider, for example, Algeria. They export to Europe 11.5 million tons. So what will happen in the near future if we have to import hydrogen instead of natural gas? So we are kind of putting some stress also on our neighborhood that are currently selling us their natural gas. And also, what is renewable hydrogen? Because we set this target, but renewable hydrogen at the time was not defined. So what is mean for renewable hydrogen was unclear at the time. This strategy has several actions. Basically, we can summarize them in: Europe is willing to support research and development, which is good. Being in a university it's good. We have financial support for the transport sector and the hard to abate. So the strategy of the European Commission is clear. They want to address firstly transport sector and hard to abate industries. For sure, European Commission and Union in general will set a lot of rules, because European Union, as I usually said, loves rules, which could be good, but if the rules are not efficient, they can put some constraint in the market development, and I will show you in the next slide what I'm talking about. And there is also a very large infrastructure planning for future application of hydrogen in all the sectors. So the problem is where we can produce hydrogen, renewable hydrogen, and how we can transport it across Europe. And what are the first results of this hydrogen strategy? There are a lot of investment now on the papers, and also approaching the ground in terms of real investment and plant realization. And if we look at this number, for example, we have this investment, 5.4 billion euros to be invested, supporting a national initiative in the European Union. And this is good, but this is just a water drop in the ocean, I would say, because if we look at the numbers that the European Commission gave us in terms of expected investment to reach the target they set, we are talking about 1,000 billion euros that are requested by 2030. And it's, a large amount of money, and European Commission has not enough money to invest. And so most of the investment are expected to come from private sectors, but there are a lot of open questions about CapEx, OpEx related with the renewable hydrogen production. And it's still far from being a convincing market for a lot of investment, or at least this is my perception here in Italy. And about rules, recently the European Commission gave a definition of hydrogen, renewable hydrogen, which is obviously good in terms of having a rule that is clear, but they put some requirements that can be a little bit that can create some concerns, like these additionality requirements. So you have to produce your renewable hydrogen with renewable electricity that is additional with the one that is already installed, and you have to produce simultaneously. Simultaneously, obviously, that doesn't mean second per second, but there will be like hour check or 15-minute checks or something like that. But anyway, it's something that have to be taken into account, and hydrogen has to be produced in the same area where renewable electricity is consumed. So this poses some restriction to the idea, for example, of having, let's say, PV in the southern Europe, wind in the northern Europe, and then hydrogen generation close with electrolyzer to the end users. It means that probably the target is more on the generation of hydrogen where the renewable sources are available for power generation, and then we have to transport this renewable hydrogen. I don't know which approach is the best. Probably there is not a unique answer, but the direction that the European community take is this one. And if we look at the investment expected for the private sector, we are going in this direction. This is the European hydrogen backbone, and what is expected is to create bio-repurposed natural gas line and new hydrogen pipelines and infrastructure able to connect hydrogen transport from different regions in Europe. And obviously this is coherent with what I presented in the previous slide. And if we move to Italy, the situation is quite similar, I would say, to the picture of UK that Oliver gave us before, because we have a high dependency from natural gas that is also used for power production. So we have a lot of power production plants that are fed by natural gas, which was good for us to reduce our CO2 emissions, moving from coal and oil to natural gas. And we also increased efficiency, and we increased for sure flexibility, as Oliver showed. But we are now, I would say, under this umbrella of natural gas, and this kind of relation, strong relation, put a lot of stress on the electricity price. And if we look at this map in my slide, you can see that the effect of using natural gas can be some way penalizing, no, for electricity production, because with the higher price of natural gas, you will have, in Italy in particular, higher price for electricity generation. And what about hydrogen strategy in Italy? Well, that's an interesting question that I posed to myself. Indeed, we are still missing a national hydrogen strategy, which is quite strange, because in the meanwhile, there are a lot of projects started. Here I put some Italian lines taken from websites of newspapers and so on. And it seems like there is a kind of confusion now in Italy. We have this so-called preliminary guideline for the strategy development. So it is not a real strategy, but something that can give an idea. We would target a production of 0.7 million tons of renewable hydrogen in 2030, but it is not clear how we are going to use this renewable hydrogen. And as in Europe, we have a demand already existing of hydrogen for non-energy purposes. And more or less, as you can see, our strategy so far, or preliminary strategy, is focused mainly on the substitution of this fossil fuel-based hydrogen with renewable hydrogen. But at the same time, we already started some project for hydrogen production, hydrogen generation for the transport sector. So it's a little bit, yeah, it's a situation that is not so clear now in Italy in terms of general strategy, what are the objectives and when we plan to use this renewable hydrogen. So we are still waiting for a national plan. Anyway, in the meanwhile, there are a lot of projects growing because there are the European funds, there is interest on the topic, and I will show two projects connected to the Ravenna area. Ravenna is a city in the central north part of Italy, close to the Adriatic Sea, with a port, with the oil and gas cluster, with a connection with the highway. There are a lot of depleted offshore natural gas platforms. The idea is to use all these infrastructures producing renewable energy and use a part of this renewable energy, renewable power, to produce green or better renewable hydrogen. Here you can see this plan to have offshore installation, both wind and floating photovoltaic panels. And the idea is to produce this renewable power offshore. And there is a plan, still work in progress, as I wrote in my slide, also to generate hydrogen. It's still unclear if they want to do it offshore as well, or they want to have the electrolyzers onshore, and how this can be managed. But we have these big projects on the pipeline, and another one in the same area. It's interesting to show. It's not related with hydrogen, or better, renewable hydrogen, but it's interesting because it's a kind of different approach to reach the same target, that is decarbonization. Here they're planning to store, separate and store carbon dioxide. It's interesting because there is a connection. One of the CO2 producer in the area is a steam methane reformer to produce hydrogen for non-energy purposes. It's used by the oil and gas and chemical industries that are in Ravenna industrial cluster. So it's interesting because in this area we have different approach to solve the same problem, and together with the companies and the local authorities, we are making some economic and environmental evaluation, because yeah, it's complicated, no, to compare such different approach and to decide what is the best choice. So these are more or less the frameworks, and what are the challenges and opportunities from a university perspective in Italy. I will just give you a few words about that. And when we talk about hydrogen, we have renewable hydrogen in particular. We have to start from a problem in terms of land availability or land consumption. This is something that sometimes is neglected. So we are looking at efficiencies, at costs, water consumption, raw materials, consumption, etc. But we forget about land. So if you want to produce renewable power, for example, to substitute what can do a traditional natural gas plant, here I put a picture of a of a natural gas plant that is located in the south of Italy to have better condition for photovoltaics in the comparison. The red area, it's the area that is occupied by the natural gas plants that produce a certain amount of energy. If we want to produce in the year the same amount of energy without considering storage needs and the differences between power generation and demand, so without addressing this topic, we would need an area that is equivalent to the one showed in yellow or orange in the slide. So it means that we can do that, but we have to keep in mind that producing renewable hydrogen and with the wind generation, it's more or less the same. So we have to consider a lot of land consumption. Land consumption is a major issue, and probably that's why in Italy and also in Europe we are considering moving offshore this kind of installation, because we don't have room or space to do that at large scale. But obviously, renewable power is not enough. We need storage. We need storage, and across the value chain to produce hydrogen or to transport power to be used, for example, for the electric mobility. Yeah, we need infrastructures, and there are efficiencies, in transporting and in transforming energy across the value chain. It means that we need large storage capacity, and at the same time we need to improve the efficiencies that are still too low. So we have to work on the technological points of view and on the system. And these are the challenges. And what is interesting for me, it's also talking about, and this is the last slide, about what are the opportunities in the next years for companies, for research center, for university. So there is still a lot of room for efficiency improvement in single equipment, but also in the overall system. And integration could be a good answer, especially at the beginning. So if we can create systems that together can increase their efficiency, it could be good also for renewable energy generation. And obviously we need solutions to target this storage demand, and maybe underground hydrogen storage is something that we need to explore, because if we look at the bigger framework and not to very small application or specific application, for sure we will need a lot of storage capacity. This can be given by the existing natural gas infrastructure. Yes, if we are talking about pipeline, but we need to explore also underground storage. We have a lot of natural gas that is stored underground also in Italy. And if we switch from natural gas to hydrogen, we have to take this problem into account. But I mean, once again, it's a challenge. So we need to test, we need to prove that it is feasible and what are the problems and find technological solution. Then we need to reduce the cost for sure. And this can be done in several ways. One is a mass customization approach applied to energy products and services. So we need more flexibility, more automation, more digitalization in the value chain, in the hydrogen value chain. While now most of the hydrogen equipment manufacturers are small and medium enterprises with a limited capacity of going in this direction. That's why we need to move into this kind of products that can be more flexible. And finally, rules and standards. These are really important, but we need a framework that can facilitate hydrogen adoption and not to put too much constraints. And also, I would like to stress this point. It's important, since we are at the beginning of this hydrogen economy, it would be important not to put constraints among countries or among, for example, United States, China, Europe, Japan, but to work together to have common standard, so the market can be wider and we can have this cost reduction faster. That's all. I hope I will stay on the time more or less, and I'm here for your questions.
Thank you very much, Marco. Very useful, very informative presentation, and yes, you were within the time limit, so brilliant. Oliver, if you could turn on your camera as well, so we can actually go through some questions, some discussions, and so on. Eugene, would you like to introduce yourself as well?
Sure.
Yeah, I didn't get a chance to actually introduce yourself, so go ahead.
Hello, my name is Eugene Holubniak. I'm a director of Hydrogen Energy Research Center at the School of Energy Resources, University of Wyoming. Part of the webinar series between the Cardiff University and University of Wyoming, and happy to be here.
Excellent, thank you very much. And I would like to remind all audiences that they can use the Q&A sections under the Zoom in order to put their questions. But to start with, I thought it might be useful to actually ask for Oliver's, Eugene's, and Marco's comment about hydrogen supply chain and how mature or ready supply chain for low carbon hydrogen is at the moment. This is somehow linked to your last point, Marco. So you talk about harmonizing standards and collaboration across the whole, across different countries. And I think in terms of supply chain, we can kind of link that to this international collaboration as well. So I wonder if you could comment on that maturity of the supply chain. What are the bottlenecks in that area as well?
Oh, yes. Well, what we are now experiencing in Italy, it's a huge demand, a lot of demand in terms of hydrogen production. So there is a lot of requests in terms of electrolyzers, for example, but the manufacturers are limited. And what's happening now is that projects are financed, are granted in some cases if there is a national or a European support. But then the problem is to find someone that can supply you the electrolyzer on time. We have now experience of some companies, European companies, that are making offers, and I mean, the shipping, for example, is foreseen in 2 years, not before, because they have already the portfolio that is full, and they are still hesitating in increasing their manufacturing capacity because it's unclear now if the market will go on this direction. So what will happen in the next 3 years? So if they follow the market, they can increase their production capacity, but they're still reluctant on doing this because there is a lot of uncertainties about what will be the incentives in terms of capex. There is this hydrogen bank in Europe, but it is still unclear how it will work and how it will finance the OPEX costs. So there are a lot of uncertainties, and this creates a lot of problems, I think.
Thanks a lot. I think I'm going to actually go to Oliver now, ask his comment on this supply chain problem. But what you described, Marco, remind us all about this classic problem of chicken and egg in hydrogen economy. So demand need to be there in order to justify supply, but before actually having a supply capacity there, would be very difficult to stimulate demand. Oliver, would you like to add on that?
Yeah, I guess it depends on what scale is being referred to. So if it is the supply chain to procure what's needed for a production small-scale storage refueler for a bus fleet or something like that, then that's relatively straightforward. Yes, there might be supply chain delays from manufacturers that Marco referred to, maybe electrolyzers, but that's fairly straightforward. When it comes to the larger scale, which kind of accelerates the larger scale of availability of hydrogen for elsewhere, and that's kind of less so at first renewable, but low carbon hydrogen with CCS, you then start to have different chickens and eggs in different places all happening at the same time. So the challenges for that is around support structures for final investment decisions beyond all of the design stages, for the final investment decisions of businesses to be able to deliver so that production can happen as storage of hydrogen is available, and that the transport business model is there as well to enable it to be taken from storage or production to the first consumers of it. And probably the initial consumers of it might well be those who are changing over from grey hydrogen to blue hydrogen, really, and then branching to other industries. And to have that CO2 pipeline for disposal of carbon dioxide in the geology that used to store natural gas. When mentioning storage, though, we've got a number of projects with salt caverns ready to go for storing hydrogen as part of these projects, but also there's the possibility for storage in spent gas fields as well. But I think the main blocker, the main bottleneck, is probably all around policy, overall policy certainty, because not having policy certainty, which is all mixed up by party politics in government and the periods that governments are in government and when the next election comes along, and the difference of opinion maybe of one minister to the next. We've changed ministers a lot in the UK and they've got very different views, prime ministers and ministers. So policy certainty is difficult. It's affecting the manufacturers on being able to commit to changing their production lines to be able to have things in place to meet what demand there might be. So policy.
Well, interesting. So lack of a strategic long-term policy and signals is
there is a hydrogen strategy in the UK, and there's commitments to spend money supporting investment, but I think Germany came over recently to say what their hydrogen strategy version 2 was and how much money they're putting into it. And I think it was probably a complete embarrassment to the UK of how much it swamps what the UK are looking to do. So yeah, mixture of all that, I guess.
We had some discussion around electrolyzers by Marco. You mentioned blue hydrogen as well, and my understanding is, again, producing hydrogen from a steam methane reforming approach has been around for quite a while in industrial places and so on. The challenge here is the capturing side of that, which may have some technical or kind of economic challenges, and also the storage of that. Eugene, I understand that you're working on this underground storage as well. Would you like to comment on this in terms of the technical maturity of CCS and blue hydrogen pathways, and any comment on the kind of cost competitiveness of that?
Sure, happy to comment. The answer on the CCS, it's a very mature technology at the moment compared to hydrogen, let's say. It is not fully commercialized. It is going through the transition, becoming commercial technology. But there are multiple, not only announcements, but actual projects that move forward. One of the indicators of that, the readiness on the USC Class 6 permits that are currently in the pipeline at the Environmental Protection Agency here in the United States. And the recent quote from what I understand, and also if you look at the website, it's about 100 applications that have been submitted. So that kind of indicates, not only the interest, but also the projects moving forward. Many of the projects are actually operational today, and or getting ready to be operational. So that's on the CCUS side. On the hydrogen storage side, that's a very different realm. So in terms of the storage in salt caverns, yes, that is sort of commercial at the moment. There is not a large amount of projects, but there are more and more being announced, and there's a large scale project in Utah, and so that we kind of know and understand how to do. The depleted oil and gas fields or saline aquifers, that is not a commercial application yet. We don't know what to do about it, and not gonna know for the next couple of years at least. So there's more research that needs to be done. I actually have a follow-up sort of a comment and a question to both Oliver and Marco. So we are planning the next episode in the series of these webinars is going to be on policy. So we'll have policy experts talking about those missing pieces, and yes, it is definitely one of those areas that are critical to move forward, and certainty and understanding the rules, just like you, Oliver and Marco talked about. But my question would be is, Oliver, you mentioned, the scale issue. So, on smaller scale, supply is available. On the larger scale, it is not. Could you clarify what is for you the scale? And could you put it in a perspective, maybe a percentage of the sort of natural gas industry in the world, just to kind of, or your given country. So what the scale? What is the scale of hydrogen economy? What do we see today, and what do you foresee in the next, let's say, 15, 20 years?
Well, the scale of hydrogen demand depends upon the pathway to the 2050 target. Which plausible pathway to the 2050 target? So it could be anything from anything up to something like 450 terawatt hours of hydrogen a year as an upper end for all different demand sectors. But as far as what happens along the way, there are currently government targets for delivery of 10 gigawatts of hydrogen production capacity, low carbon hydrogen production capacity, as a twin track approach between green and blue hydrogen. And that's the focus of delivering that capacity first in those clusters for those first customers. But there's a great deal of demand for hydrogen in places that don't have the opportunity to store CO2. And on top of that, sorry, there's a bit of a digressing here, but on top of this issue with hydrogen production and low carbon, making it from natural gas, it's the need for carbon dioxide shipping as well, as part of that. But I think although industrial demand is going to be a significant leading customer to grow the production, storage, but the economy overall and the transportation of it, I think initially the power generation target in the UK 2030 or 2035, depending upon which political party you look to, for a net zero electricity system, probably going to be giving where the initial demand will come from, and that might well be 10 combined cycle gas turbines by 2030, 2035, which are typically around about 1 gigawatt each generation capacity. Bit difficult to answer your question without having maybe all the different plausible pathways in front of me for the different terawatt hours over a year that might be required. Sorry, I don't know if that answers your
No,
question.
Oliver, I totally understand, but this is arm waving at its best, but that's the part of that question. Marco, what do you think?
Well, if we look at the strategy, for example, in Europe, this expected 10 million tons of renewable energy to be produced, they means more or less, depending on the efficiency that you consider for the electrolyzer, it's more or less 40 gigawatts of installed capacity, which is quite big. If you consider that now we are almost close to zero, so it's a very long jump in a few years, and the problem is that now it's complicated to find on the market, as Oliver said, megawatt manufacturer. So if we think about gigawatt, it means that we have to build factories to produce these electrolyzers, and once we have produced one or two, what will happen in the next 20 years? So it's something that is complicated to say, but this strategy at the end, I don't know if it is good or not, but put on the table some targets, and I think that in the next 2 years we will probably understand better if these targets were too much high, and we have to readapt a little bit the roadmap, or the market will find some way to have solutions to all the bottlenecks that we highlighted. So manufacturing processes, costs, technology efficiency, and so on. So I think that the next 2-3 years will be crucial to see if we have to move these targets, probably to lower these targets. I think here in Italy, coming back to what Oliver said, we had a change in the government and also in the ministers. We have decades of experiences in this field, so probably in UK it's something new, but here we are quite it's something normal, I would say. And what happens is that the strategy changed in the view of hydrogen. So there were a lot of projects that were on the pipeline that were a little bit postponed or cancelled, and obviously this is perceived as uncertainty. So there are some Italian companies now that can sell you products in the hydrogen value chain, but they are hesitant in investing for increasing the capacity and what I said before. So it's really complicated. That's why I think it's important to open the market, because if your national market it's a little bit hesitant, maybe there will be more demand, I don't know, in India, in Australia, in China, and if we can compete on a larger market, it's easier to scale up. I think this is one of the things that are important if we want to accelerate this economy growth.
Fantastic point. Thank you both.
Yeah, I think regarding the point mentioned by Marco and Oliver, Professor Omar Rana actually put a question asking about the timeline for development of hydrogen infrastructures, and also in kind of general timeline for other infrastructure as well. that are required, for example, reinforcement of electricity network in response to electrification of heat and transport, and so on. For the case of UK, Oliver, I understand that there are different scenarios, different pathways, each of them have their own timeline and so on. But focusing on the hydrogen side, what do you think would be the plausible and achievable timeline, considering the technical, policy, supply chain, and all those constraints? What do you think would be the achievable timeline for developing hydrogen infrastructures?
Well, hopefully some of the slides gave an example of that with the time jumps every 5 years. But so the transmission infrastructure largely being in place between 2030 to 2035, being able to balance supply and demand across the main demand centres of it in the UK, where the big clusters are, industrial clusters are. That at the same time has to involve the development of some initial new local transmission infrastructure that the distribution networks have, then be able to repurpose existing local transmission infrastructure. So there needs to be some initial new infrastructure to enable the repurposing of the rest. But the focus largely is around which clusters go first, and they're ordered. There's a track 1, which is 2 different clusters, track 2, 2 other clusters. So it focuses on 2 initially, and they're kind of the 27 to 2030 kind of mark for being up, running, delivering, extending, and meeting the needs of some not just the first customer, but some further customers after that. As far as the access to wider demand is concerned, then that all depends on how near to that pioneering infrastructure other demand is to be able to tap into it for, say, conversion of a city to hydrogen for other demand. But it's probably going to be taking us right up to 2045 to have the repurposing and the conversion of individual buildings done, if we get started pretty soon on it, when the government want to make their decision on that kind of approach in 2026. But as far as just one point with the question there, will we see a multi-energy vector future? I think the answer to that is definitely. A single vector solution is going to struggle at being able to be affordable, because you'll have to build over capacity from one end to the other of the energy system that will be underutilized. And multi-vector helps you to optimize the investment to have well-utilized assets. So yeah, I think it will be. And I've got electricity networks knocking on my door saying, we need hydrogen for home heating, we need hydrogen for this, we need to have hydrogen production on our substation sites to help us with flexibility. So that needs to go somewhere like the gas grid. Some electricity networks are perhaps not so forthcoming about that multi-vector future yet. But the realities of the need for it seem to be materializing more quickly.
Okay. Thanks a lot, Oliver. I just have one final question, but Eugene, do you have any other questions or any points you would like to make?
No, go ahead, Misam.
Yeah, because we have limited time left, so this is my final question, and it is about hydrogen ladder. I assume you all have come across these hydrogen ladders that try to put hydrogen in terms of the application in which hydrogen is most competitive on top, and then when hydrogen becomes less competitive compared to the other alternative fuels, so it comes down. If you want to actually create a hydrogen ladder for yourself, what would you put on top of that ladder, and what would you put on the bottom of that ladder? So in other terms, what application do you think hydrogen is the most competitive, and what would be the application that you feel that, okay, hydrogen can be used, but there are other better options for that type of application. Is that okay if I start with you, Marco?
Yes. Yeah. No, it's this is a very good point, because we were talking before about these multi-energy systems, and there are these tendencies to promote one solution as the best for everything, kind of holistic solution that can solve all the problems. But I don't think this is the right approach. We need to combine different energy sources, vectors, and whatever, depending on the local availability of resources. And in general, so it's not easy to answer to your question, but I will try to. I think that when we talk about hydrogen, we can see two different applications. The one is the hydrogen as a feedstock. So here the competition is between hydrogen produced from electrolysis and hydrogen from natural steam natural gas reforming. And as far as I know now, if we have carbon capture and storage, probably this option can be more economically sustainable. I don't know, because there are a lot of concerns, and it's difficult to assess which could be the environmental impact of doing this comparison, because you have to consider methane leakage, and there is a strong debate about this. If we look at energy use, hydrogen production for energy use, I think that probably the best options are hard-to-abate industries and heavy transport, because they are two sectors in which it's difficult to find alternatives to fossil fuels. And electrification, it's more challenging, probably. So hydrogen can give you a higher capacity of reaching elevated temperature for hard-to-abate industries, and to have higher energy density on heavy transport sector. If we move to other sectors, probably hydrogen is far from being competitive. I mean, we can do demonstrator pilots and whatever, but if we think at a large scale adoption, I don't think that the economics will stay on our side. So basically, I agree with the European Commission strategy, to address first transport and hard-to-abate. It makes sense to me. And that's my opinion.
What would you put on top of your ladder, Oliver?
I think I'd push the ladder over, really, and put it down. I'll go and put it in my garage, probably. This obviously, certainly, as Marco said, there are use cases where it's necessary as no alternative, kind of pretty much like the steel mills that I mentioned in one of the presentation slides. That needs 1,400 degrees. But the kind of the ladder-like approach makes an assumption that all those demands are within the same area, or can have their own production and supply area, and these different demands can be considered separately, siloed, which happens in policy advising, making, and regulation. And although we have these significant centers of emissions from power generation and major industry, we have so much non-clustered industrial demand. I think Make UK says something along the lines of 100,000 industrial premises outside of industrial clusters that will need hydrogen. Or hydrogen would be a serious contender for those places, and they are amongst places where there's heavy transport, places where there are people living and working at those places, and places where there's local generation of electricity to balance supply and demand. So I love the idea of trying to be able to prioritize, and there's certainly some prioritization can happen, but this is where because it's all interconnected, all the different demands, it's an economy-wide approach for hydrogen alongside a total system design to keep it as affordable as possible, working with what the needs are for increasing capacity of electricity networks for electrification, for example. So I'd knock it on the floor and look at it more in the whole. I did smile when you mentioned the hydrogen, Madam. Thank you for mentioning it.
I think that was quite good answer, because that highlight the importance of this whole system approach and taking into account the interconnections between different vectors, sectors, and also place-based agenda, which is currently actually is being paid lots of attention to. But before we wrap up, Eugene, would you like to answer this question as well?
No, I think for the time's sake, I think we need to wrap up the discussion. We kind of went a little bit over time. I just wanted to mention that our next episode is going to be focused on policy, and that was all from me. Brilliant.
Thanks a lot. Thank you very much, Oliver. Thanks a lot, Marco. And thanks a lot for attending these webinars. The recording is going to be available on the website, and you will be informed about that. Many thanks, and hopefully see you next month.